Alright, so it's time to get back on the Fein 7115 project. There's a couple of things I need to do. This right here is the switch, the Marquardt switch. And I think I'm going to go ahead and desolder these wires and put all new wires in here. So hopefully we'll see how these come out, if they're going to be difficult or not. So I threw a little bit of flux on there. We'll see if we can get that solder out with this braid. I also really didn't like the way they did this connection right here. So I think I'm going to go, even though those two terminals are the same, I'm going to actually pull those out to a point out here, just to make it a little bit easier. Yeah, definitely we're pretty liberal on the solder there. So this right here is the end of the cable with the switch and the capacitor on it. And as you can see, not the greatest soldering job of all time there. So I think what I'm going to do is I'm probably going to have to keep this ring terminal, because I believe that was some kind of grounding lug. And we'll just desolder all these connections, and so we have fresh terminals when we rewire this thing. Kind of makes me wonder if this probably wasn't a repair, because I really doubt that this was done in this fashion originally at the factory. So this might have been a field rework at one time. Considering its age, it's not that surprising. You know, it's really interesting. You look at the ratings on the switch. 10 amps, quarter horsepower. It's a little bit overkill, considering this switch was only 2 amps. So I like to open up these old switches and clean out the contacts. Newer switches you buy are totally sealed, but these old style ones you can typically take apart. So it looks like we got two different size terminals here. On the one side, to the T of the Marquardt, we got a smaller terminal, and the one on the M side over here. Not exactly sure the reasoning for that. Look at like a line load type of deal. But this switch has 6 terminals. It's basically a double pole, double throw type of switch, where you have a common, which I believe would be these ones on the top, and then you have a normally open, normally closed side. It looks like we got the actual contact numbering up here. So you got 1A, 1B, 2A, 2B, and then underneath all that gunk, you see a 1 and a 2 in there. So the next thing to address are the brushes. So looking at the manual or the documentation, they said to replace the brushes when these get below 5 millimeters in length. And I measured these and they're just under 5, so I'm guessing that's probably why this was disposed of or sold. And of course you're not going to find these sold by Fein anymore, and they're a pretty oddball size. So the biggest problem with finding replacement brushes is not necessarily the size, but the termination. Because this is not a typical way that brushes are terminated these days with ring lugs. Typically you would have a spring with just a tab on the end, or you may have something like this with a shunt and then a fast on or quick connect. So one thing I wanted to point out is how these are terminated, and I brought this to a couple of people at work who deal with electronics assembly all the time, and they said they've never seen anything like this. What it looks like happened is the copper was actually flattened, and then it looks like it was ultrasonically or spot welded from the back. This is not a typical practice you see these days. So after searching for replacement brushes, the closest I could find that met the width and height were these ones right here. The only issue is that these are terminated differently. They have a spring and a tab on them. So what I'm going to need to do is to cut off this tab and then put a ring terminal on there to match the old ring terminals. Alright, so I got the one of them crimped. I really didn't do much to this transformer. I think in the future I might make my own transformer for this. But for now I think I'm just going to keep everything the way it is. But I didn't even actually power this up in the last video because I wanted to check out everything, make sure there was no problems. So let's go ahead and put this back together and see if it actually works. So one thing I want to do here is actually put some proper ferrules on these two connections. So a ferrule is just a, it's just like a little sleeve. So I probably have one that'll fit that size in here somewhere. There's a couple different ways to attach these. You know, mostly in the industrial world you would use a one that works for all sizes. But you can also get these ones that work for basically specific sizes. Alright, there we go. We got everything nice and tidy. With the ferrules and the strain relief. So, next thing we'll do, go ahead and pop this guy on the cover, and then we can wire up the low voltage side, the secondary side. And actually, before we do that, we probably gotta attach the handle. You know, somebody was asking what nut drivers were good for, and it's really stuff like this. When you have a basically a nut on a screw that's a lock nut or has a lock washer on it, these are the best situations to use that. So there's like a fiberglass gasket around here, and that kind of acts like a seal, and also as kind of a lock for these screws to give it some positive pressure. So I guess it really doesn't matter which side goes on which, because it is a double insulated tool. So that's probably why they haven't labeled or colored these wires, because it really doesn't matter. So I don't have any 220 plugs in this room. So what I'm going to use to try to power this is one of these universal converters. And I really don't like using these because I just don't trust them. If you want to catch somebody's house on fire, just give one of these to them. I actually don't even like touching the chassis on this. They're usually not isolated. We got the European style plug here. So I got everything wired up, but I haven't turned it on. I'm just going to measure that voltage with this Keithley 197A. It's just whatever I had in this room. Polarity should not matter. Go ahead and plug that in. And like I said, I don't even like touching the chassis on this thing because it's so finicky sometimes. Yeah, it looks like it's just picking up noise. Go ahead and measure the resistance across these two leads. Alright, so we're not getting anything, so I did not check the fuse that was in there, so why don't we go ahead and open it up and check that. Alright, so I checked the fuse, and the fuse is fine. I checked continuity from this cable to that terminal block, and one of the poles I'm not getting anything, so I think there must be a loose wire inside this connector, so let's go ahead and open it up. Alright, so that one has continuity, but that one does not. so next thing we'll do is we'll actually take it out and test the actual wire. I'm going to do that. We'll just cut off these ends. Alright, so I even pulled the terminations off the one that I did before. I'm still not getting continuity on the black or the brown wire. So it looks like this cable's toast. There's a break in the cable somewhere. So it looks like I'll have to go scrounge up a new cable. Alright, so I stripped away this cable to try and see where the break was, and I think I found it right here. Yeah, so this I think was about the spot where this cable clamp was clamping. So I think it was just from fatigue. Not necessarily it was clamping too much. I think every time the cable was moving there. I don't think we quite need to go to something like this. This is like the kind of cable they use in CNC machines. It's actually rated for, you know, hundreds of thousands of flexes. Extra guard flexible control cable. Stuff's like a couple bucks a foot. But I think I'm just going to replace it with a standard power cable. So it's like, this is just something I found. Anytime they throw stuff away at work, I tell them to give it to me. And I'll find something to do with it. So I think that's a Dell part number. So this probably came with like a server or UPS. Because I don't think they would include this type of cable with most normal products. It's like 14 gauge. So I'll just cut off the ends of this and just re-terminate both ends. And I got a ton of these, so it's not like I really need this one. And again, we don't need the ground wire, so we'll just cut that off as close to the end here as we can. So here's a little tip for people using these ferrules. In like industrial production, when the QA guy inspects these, he actually looks for the copper out the end. So these types of ferrules are actually designed to be clipped off at the end. That's kind of what those notches are for in the crimpers. And we'll just do the same thing on the opposite side here. You know, I just noticed on this piece of crap, 4,000 amp. I would hope that that's a typo. Alrighty, so I think I got everything back in order here. So I think we'll try this again. See what we get. Alright, it looks like it's working. I'm getting 49 volts AC. Now this unit, it's not calibrated. It's actually how I got it. They threw it out. It says something wrong with it. So it probably drops down to something like around 42 volts under load. So that was the problem with it. It was sold as not working. So looks like that cable was a culprit. Alright, so let's go ahead and button this up and then we'll move on to the main tool. Okay, so we're ready to start assembling the main tool. The first thing I'll do is I'll try to get this switch back together. So this is probably the most complicated double pole switch I've ever seen. I checked, it's got 13 line items, 21 pieces. A couple of things I noticed after cleaning this out, there was so much gunk in here you couldn't even see that there's an R and an L down in there in red. So I just used some quick drying contact cleaner on all this, which is meant for electrical parts. I certainly do not envy the person who had to assemble these all day. So I had to go back and watch the first video because I kind of forgot how everything goes together here. So I think I pretty much have it. I think part of the issue is that this drawing really doesn't match up well up here with what was actually installed. So right here is the part that actually engages the bit, and this has a spring loaded right here. When it reaches the set torque, it will actually, basically cam out. This spring goes in here, and this ball bearing pushes up against this shaft. Then we got this piece, this shaft right here, goes in here with the spring on it. And then we got two little ball bearings which go in these grooves right here. I think that's what these ones are for. And then we have a whole bunch of tiny ball bearings that go up in here in this bearing. And then this piece goes on like that, bronze bushing on there. And then this little pinion or gear goes right on there. And then finally this piece goes like that. So I'm just going to use some standard bearing grease for lubrication. So I guess I'll try to get all these tiny ball bearings. All right, well, got them in. I'm not exactly sure what they're supposed to be doing in there, because they're definitely not handling any load. It might be some kind of balancing feature, because as this spins up, those are going to basically redistribute themselves uniformly. So I'm not really sure what the purpose of those is. So now what I got to do is get these two ball bearings in this little slot up here. And I think I'm going to use this puller to help me out. So I can just basically do this by hand. It's not a lot of force. So basically right down in there, there's a spot for a ball bearing on each side. Alright, so that piece should be good to go now. Alright, I just pressed that on there off camera, but looks like we got everything together here. We should be able to just screw this in into here. Okay, I think we're ready to move on. Okay, I think the next thing to do is to put this brush holder in. That goes all the way in the back there. So we should be ready to pop this guy in here. Remember, it was a very light friction fit. We should be ready to pop this guy in here, bar the brushes aren't in there yet. But let's just see how everything fits. So I actually took this to work to do a couple of things, extend some of these wires and actually install these brushes. And I used a Variac to actually test this. Now the original schematic wasn't that clear, so what I ended up doing was actually drawing my own. And I hooked everything up, and the thing was going over current. I set the limit to like 50 watts, and it was hitting 50 watts pretty quickly. I turned it up a little bit higher, and I was starting to get a little bit of a weird smell. So I stopped there. This thing is only rated to 1 amp. I think that there's a short in the field windings is my guess. It could also be down here in the armature as well, but I actually measured all the bars on there, and they were all coming out to about the same resistance doing the 180 test. So I'm thinking that this thing, it might be one of those cases where it's beyond economical repair. I knew when I got it that it was not working. So this video is starting to get a little bit long, so I think I'm going to stop it here. I'm going to button this up as best I can, and maybe in the future we'll take this apart and see if we can repair that armature or field windings. But this may just be a case of one that's just a display case item. But at least we got the transformer fixed, so in case we run into any other 42 volt tools, we can use that. But this thing looks like it might be unrepairable, considering that armature, you're never going to find one 42 volts. There's no way. So sorry about this being anticlimactic, but I think that's going to wrap it up for this one. Hopefully you guys got some enjoyment out of that, and I'll catch you guys next time.